Imagine you've lived your entire life in a massive metropolis. You knew your street, your neighborhood, even the adjacent blocks. You were certain you understood how this city was laid out. You drew maps, you named the squares and avenues. And suddenly, on a September day in 2014, architects show up and tell you that all your maps were wrong. That what you thought were scattered districts are actually parts of a single, giant, pulsating organism, the existence of which you didn't even suspect. And the scariest part? You don't just live in this organism. You are a cell in its bloodstream, and you are being swept through a vein at the insane speed of 600 kilometers per second, toward a heart that no one has ever seen. This is not science fiction. This is what happened to us, to humanity, just over a decade ago. We thought we knew our cosmic address: Earth, Solar System, Orion Arm, Milky Way, Local Group, Virgo Supercluster. It sounded solid and clear. But in 2014, a group of astronomers published a paper that upended cosmology. They erased the old borders and drew new ones. It turned out we live inside a structure so colossal that it takes light 500 million years to cross it from edge to edge. It is 100 times more voluminous than we thought. It contains 100,000 galaxies, and each of them is an island of hundreds of billions of stars. And this structure has a name that sounds like an ancient incantation: Laniakea. But Laniakea isn't just a really big pile of stars. It is something fundamentally different. It is not an object in the traditional sense, like a rock or a planet. It is a dynamic system. It is a flow. It is a gravitational waterfall 500 million light-years wide. And we, our tiny planet, our cozy Milky Way, we are just drops of water in this waterfall, falling into the abyss. Where are we falling? What lies there in the center, at the point where all the currents converge? Why do scientists call it the Great Attractor? And why might this monster, pulling millions of galaxies toward itself, be merely a toy in the hands of an even more terrifying force? Today, we will learn the truth about our true home. We will break down how you can map something that you are inside of. We will see how astronomers learn to see the invisible by tracking not light, but gravity. And most importantly, we will try to understand what awaits us at the end of this fall. Are we merging into a single supergalaxy, or will we be torn apart by the expansion of the universe into lonely atoms? Welcome to Laniakea. Welcome to the Immeasurable Heavens. But to understand the scale of the Laniakea discovery, we need to go back a bit and understand how we pictured the universe before this. How did we draw maps of the starry sky? It was pretty simple and logical. We looked through telescopes and counted galaxies. If there were a lot of galaxies in one spot, we called it a cluster. If there was another bunch of galaxies nearby, and they seemed close to each other, we grouped them into a supercluster. It was a visual method. We were like ancient geographers sitting on a mountaintop drawing a map of the world. I see a forest. I draw a forest. I see a mountain. I draw a mountain. That is exactly how we assigned ourselves to the Virgo supercluster. This is a huge structure centered on the Virgo cluster, located about 50 million light-years away from us. We, the Milky Way, and our neighbor Andromeda are on the outskirts of this metropolis. We are the suburbs. And for a long time, it was believed that the Virgo supercluster was our neighborhood. This was our final address, a huge, flat pancake of galaxies about 100 million light-years across. It seemed like enough. 100 million years of light travel. That's enough to make anyone feel insignificant. But there was one problem, a problem that kept astronomers awake at night: motion. You see, there are two types of motion in the universe. The first type is Hubble expansion. The The universe is inflating like a balloon, and all galaxies are moving away from each other. That's clear. That's the law. But if you subtract this expansion, you are left with what is called peculiar velocity, the galaxy's own movement. This is how galaxies dance under the influence of their neighbor's gravity. And this is where the numbers didn't add up. Our galaxy, the Milky Way, is flying through space at a speed of 600 kilometers per second relative to the cosmic microwave background radiation. That is very fast. That is 2 million kilometers per hour. Where are we flying? We are flying toward the constellation Centaurus. But if you calculate the mass of the entire Virgo supercluster, all those thousands of galaxies we saw on the maps, their gravity simply wasn't enough to accelerate us to such a speed. It's as if you saw a river flowing at a furious pace, but the slope of the riverbed was almost zero. Something was pulling us. Something huge, hidden beyond the horizon, behind the dust clouds of our own galaxy. We felt the presence of a ghost. We called it the Great Attractor. But we didn't understand where its influence ended. Where were the limits of its power? Where did our neighborhood end and someone else's begin? Old maps based on simply counting galaxies didn't provide an answer. They were flat. They didn't show dynamics. We needed a new way to see. We needed to stop looking at houses and start looking at roads, at flows. This is where Brent Tully, an astronomer from the University of Hawaii, and his team enter the stage. Hélène Courtois, Yehuda Hoffman, and Daniel Pomered. These people started a revolution. They decided not just to photograph galaxies, but to measure their speeds. They created the Cosmic Flows 2x2 catalog. It was titanic work. They measured the movement of 8,000 galaxies in our local patch of the universe. Imagine trying to draw a wind map of Earth having only 8,000 weather vanes scattered across the entire planet. It's hard, but with the help of mathematics and supercomputers, they were able to reconstruct the big picture. They subtracted the expansion of the universe for each galaxy and left only the gravitational motion. And what they saw on their screens was mesmerizing. The galaxies weren't moving chaotically, they were flowing. They formed giant rivers, streams, and whirlpools. Space ceased to be a static picture, with scattered peas of stars. It turned into a living organism with a circulatory system. And all these rivers, all these streams of matter, flowed in one direction. They were draining into one gigantic valley. Tully's team realized that the old definition of a supercluster as just a dense pile of galaxies was wrong. It's like defining the borders of a country by population density. No, borders are defined differently. They applied a concept from hydrology to space, the watershed. Imagine a mountain ridge. When it rains, a drop of water falling on the peak might flow down the western slope into the Pacific Ocean. But if it falls a meter to the right, on the eastern slope, it flows into the Atlantic. The peak of the mountain is the boundary, the watershed. All rivers flowing into one lowland form a single basin. Astronomers applied this logic to gravity. They started looking for gravitational watersheds in the universe, lines where flows of galaxies diverge in different directions. And when they outlined the boundaries of the basin we are flowing in, they gasped. The Virgo supercluster, which we considered our home, turned out to be just a tiny tributary, a small stream on the outskirts of a gigantic river system. This system united hundreds of clusters like Virgo, the Centaurus cluster, the Hydra cluster, the Pavo Indus cluster, the Southern supercluster. All of them, along with us, were part of a single whole. They flowed toward a single center, toward the Great Attractor. The boundaries of this structure were defined not by visible matter, but by invisible lines of gravitational separation. Inside this sphere, everything flows inward. Outside, it flows toward other attractors, toward other monsters like the Perseus-Pisces supercluster or the Shapley supercluster. It was a discovery on the scale of Copernicus. Our world got 100 times bigger overnight. The old name Virgo supercluster had to be demoted in rank. Now we say we live in the Laniakea supercluster. This name was suggested by David Nawa'a, a professor of Hawaiian language. Lani means heavens, and Akea means immeasurable or immense. Immeasurable heavens. The perfect name for a structure 500 million light-years in diameter. Now imagine the shape of this beast. Laniakea doesn't look like a ball, and it doesn't look like a disk. In the computer models built by Tully's team, it looks like a giant glowing feather, or like an exotic jellyfish with long tentacles, or like a neuron in the brain of a god. It consists of filaments, long strands woven from galaxies, and the voids between them. We, the Milky Way, are on the very edge of this feather in one of its thin filaments. We are far from the center. We are the cosmic provinces. But the most important thing about Laniakea isn't its shape, but its dynamics. It is a structure of motion. Imagine looking at a subway map. You see lines, stations. That is a static map. Now imagine looking at a traffic map on a GPS. You see red and green lines showing where cars are moving and how fast. The map of Laniakea is a traffic map on a universal scale. And we are in a stream rushing down the Autobahn straight to the city center. However, once the euphoria of the discovery settled a bit, new questions arose. Questions that make you feel uncomfortable. We realized we live in a basin of attraction. We know that all rivers here flow to one point. But what is at that point? What is the Great Attractor that all of Laniakea strives for? For a long time, this was a mystery because, as I mentioned, the attractor is hidden from us behind the zone of avoidance, the dust clouds of the Milky Way. We couldn't point optical telescopes there. We were blind, but radio telescopes and X-ray astronomy allowed us to peek through the dust. And what we saw there both explained a lot and confused everything even more. There, in the heart of Laniakea, lies the Norma cluster. This is a colossal cluster of galaxies, the mass of which is tens of thousands of times greater than the mass of the Milky Way. It is a gravitational pit of incredible depth. It is what forces the 100,000 galaxies of Laniakea, including us, to change their course and fall toward it. This is the heart of our supercluster. It seemed the puzzle was solved. We found our home, found its borders, and found its center. But then a second critical point bursts into the equation, something that breaks the beautiful picture of a closed system. If you look closely at the velocity calculations, you see something strange. Yes, we are flying toward the Great Attractor. Yes, all of Laniakea seems to be contracting toward it. But the Great Attractor itself is moving too. It isn't standing still. It is racing through space at an even greater speed. And all of Laniakea is flying with it. We are like passengers on a bus driving toward a cliff, but the bus itself is on a ferry sailing through a storm. Where is the Great Attractor flying? Who could be powerful enough to pull a structure 500 million light-years across with a mass of 100 quadrillion suns? The answer lies beyond Laniakea, beyond our home. It turns out we have a neighbor compared to whom our giant Laniakea seems like a dwarf. Its name is the Shapley supercluster. It is a monster located 650 million light-years away from us. It is the most massive concentration of matter in the nearby universe. And here arises a frightening realization. Laniakea might not be the final structure. Perhaps our immeasurable heaven is just a tributary flowing into an even grander river. We thought we drew a map of the world, but it turned out we drew only a map of one island in an infinite archipelago. Gravitational threads stretch further, through billions of light years, connecting us to objects we can barely make out with the most powerful telescopes. We are approaching the equator of our journey, and here we need to pause and comprehend the scale. Imagine, Earth rotates around the Sun. The Sun rotates around the center of the galaxy. The galaxy falls into the center of Laniakea, toward the Great Attractor, and Laniakea itself falls toward the Shapley supercluster. It is a nesting doll of movements. It is a cosmic dance where every step is millions of years and millions of kilometers per second. But there is another force, a force working against all of this, a force trying to break these bonds. Dark energy, the expansion of the universe. We are in a state of war. On one side, gravity, trying to gather all the galaxies of Laniakea into one giant ball. On the other side, dark energy, inflating the space between galaxies, trying to scatter them in different directions like billiard balls. Who will win this battle? This is a question of life and death for our cosmic structure. If gravity wins, then in the distant future, all the galaxies of Laniakea will merge. The Milky Way, Andromeda, the Virgo cluster, the Great Attractor, all of this will turn into one unimaginably huge elliptical galaxy, an island of light in eternal darkness. This is the big crunch scenario on a local scale. But if dark energy wins, and all modern data suggests that it is winning, the universe is expanding with acceleration. This means Laniakea is doomed. It is not a real structure in the sense that it is not gravitationally bound forever. It is a temporary illusion, a flow that is drying up. The expansion of the universe will tear the rivers of galaxies apart. We will never reach the Great Attractor. The space between us and it will stretch faster than we can cross it. Laniakea will dissolve. It will vanish like smoke in the wind. And this realization gives our discovery a tragic hue. We discovered our home only to realize that it is crumbling. We live in a structure that exists only now, in this short, by cosmic standards, moment of time lasting a few tens of billions of years. But let's return to the structure of Laniakea itself, because it is not homogeneous. Inside it, there are places that make your blood run cold. We talked about watersheds, but there are also wastelands, voids. Inside Laniakea and on its borders, there exist giant bubbles of absolute emptiness. Places where there are almost no galaxies. Right behind our backyard, opposite the direction of the Great Attractor, lies the local void. It is a hole in space that starts right at the borders of our local group. It is huge, and it is terrifyingly empty. But the most interesting part, it also participates in our movement. Remember, we said the Great Attractor is pulling us? Well, that is only half the truth. We are also being pushed. The local void works as a dipole repeller. It sounds like anti-gravity, but the mechanism is simpler. There is less matter in the void than the cosmic average. That means gravity there is weaker. And on the side of the attractor, there is more matter, and gravity is stronger. We are in the middle. The attractor pulls us toward itself, and the lack of attraction from the void sort of pushes us from behind. We aren't just falling into a pit, we are sliding down a hill into a pit. This push-pull effect accelerates our galaxy to those very 600 kilometers per second. We are sandwiched between a monster and a void, between the hammer of the supercluster and the anvil of the void. And this position determines the fate of our world. But if we want to truly understand where we live, we need to go even higher. We need to stop looking at individual clusters and look at the structure as a whole. If you look at a computer simulation of the universe on the largest scale, you won't see balls and disks. You will see a web. It is called the cosmic web. This is the skeleton of our universe. Giant filaments of dark matter, on which galaxies are strung like beads, piercing the void. Laniakea is not an isolated island. It is a node in this web. It is a place where several powerful filaments intersect. Imagine a busy highway intersection at night. You see streams of light from headlights merging, intertwining, and diverging again. Laniakea is such an intersection. The galaxies in it are not lined up randomly. They flow along these fibers. These fibers are gravitational highways. The Milky Way, Andromeda, and the entire local group are currently sliding along one of these threads. We call it the local sheet. It is a flat structure, a wall of galaxies, which is part of an even larger wall. We literally live inside a wall. On one side of us lies that terrifying emptiness of the local void we talked about. On the other side, a dense stream of galaxies rushing toward the center. And here we come to one of the most amazing and even mystical coincidences in modern science. In 2020, Italian astrophysicist Franco Vatsa and neurosurgeon Alberto Filetti conducted an unusual study. They compared the structure of the cosmic web, of which Laniakea is a part, with the structure of the neural network of the human brain. They took slices of the cerebral cortex and slices of a computer model of the universe. And when they put these images side by side, they couldn't find any differences. It isn't just a visual resemblance. The mathematics of these two systems turned out to be frighteningly identical. The number of nodes, the number of connections, the ratio of the mass of nodes to the mass of filaments, everything matched. In the brain, there are neurons connected by axons. In the universe, there are galaxy clusters connected by filaments of dark matter. In the brain, water makes up 77% of the volume. In the universe, dark energy makes up 73%. Laniakea, in this comparison, looks like one giant neuron or ganglion, a nerve knot. The flows of galaxies inside it are signal transmission. Of course, this doesn't mean the universe thinks in human terms. The timescales here are different. If a signal in our brain travels in milliseconds, then in the brain of the universe, a signal is the movement of galaxies, which takes billions of years. But the structure itself, the very architecture of complexity at the micro level and the macro level, follows the same laws. We live inside a structure that is mathematically indistinguishable from thought. Laniakea is a frozen thought of gravity. This discovery forces us to look at our place in a new way. We aren't just dust in the void. We are part of an incredibly complex system, the functionality of which we can't even imagine. But let's return to physics, to our neighbors. Because if Laniakea is a neuron, it must be connected to other neurons. And they are there. Our nearest giant neighbor is the Perseus-Pisces supercluster. It is a colossal wall of galaxies located about 250 million light-years away from us. On the cosmic flows maps, you can see that Laniakea and Perseus-Pisces almost touch, but they are separated by an invisible border, a watershed. Galaxies on one side of the border flow toward us, into Laniakea. Galaxies on the other side flow into Perseus-Pisces. These are two different basins of attraction, two different oceans that will never mix. And on the other side is the Coma supercluster, Coma Berenices. This is a legendary object. It was by observing it in the 1930s that astronomer Fritz Zwicky first suspected the existence of dark matter. He saw that galaxies there were moving too fast to be held together by the visible mass of stars alone. Something invisible and heavy was holding them together. Now we know that Coma is another powerful node in the cosmic web. Neighboring our Laniakea, we are surrounded by titans, but we aren't standing still and watching them from the sidelines. We are part of the movement ourselves. And here we come to the main intrigue, to what astronomers call the Shapley problem. Remember we said that all of Laniakea is flying somewhere along with the Great Attractor? We found the culprit. It is the Shapley supercluster. If Laniakea is a city, then the Shapley supercluster is the capital of the empire. It is located 650 million light-years away. It contains a mass equivalent to 10,000 Milky Ways. Its gravity is so powerful that it reaches us across colossal abysses of space and drags not only us, but our entire huge Laniakea toward itself. Imagine this nesting doll. We fall toward the center of Laniakea. Laniakea falls toward Shapley. And Shapley? Where is it falling? Is there an end to this chain? Recent data suggests that perhaps Shapley isn't the final point either. Beyond it loom even larger structures that we can only vaguely see through dust and distance. Perhaps our entire local universe is a river flowing toward some unimaginable ocean located beyond the event horizon. But let's talk about speed. We said 600 kilometers per second. The number sounds dry. But what does it really mean? Imagine you walked outside and looked at the sky. In the time it took you to take one breath, Earth flew through space the distance from San Francisco to Los Angeles. In 1 second, we are riding a cannonball. And yet, we feel nothing. The coffee in your cup doesn't spill. Why? Because it is free fall. We are falling into a gravitational pit. According to Einstein, falling is indistinguishable from weightlessness. Our entire galaxy, all the stars around us, are falling with us. This is the equivalence principle. We are rushing toward our fate, but to us, it looks like rest. It is the grandest illusion of stability one can imagine. And here the question arises, what will happen when we get there? What will happen when the Milky Way reaches the heart of Laniakea, and then the Shapley supercluster? This is a cosmic apocalypse scenario. Colliding galaxies are beautiful only in pictures. In reality, it is chaos. If we flew into the dense core of a cluster, the interstellar gas of our galaxy would collide with the gas of the cluster. A stripping would occur. Our galaxy would be stripped bare. It would lose all its gas. Stars would stop being born. The Milky Way would turn into a dead red galaxy drifting among thousands of similar corpses. But there is good news, or bad, depending on how you look at it. We will never get there. We are approaching the most dramatic part of Laniakea's story, its future. And that future is decay. We already mentioned the battle between gravity and dark energy. Well, the news from the front is grim. Dark energy is winning. The universe is expanding with acceleration. This means space between galaxy clusters is stretching faster than galaxies can fly toward each other. Laniakea is a doomed structure. It is not gravitationally bound in the way the solar system or the galaxy is. Earth will never fly away from the Sun because the Sun's gravity is stronger than the expansion of the universe at such small distances. The Milky Way will never fall apart. Even the local group, us and Andromeda, will stay together. We are bound tightly. But Laniakea is too big. 500 million light-years is too much. On such scales, dark energy is already stronger than gravity. The flows we see now, these rivers of galaxies, this is the inertia of the past. It is what started billions of years ago. But the fuel for the movement is running out. Astronomers ran simulations of the future, and they showed that Laniakea will tear apart. It will break up into several isolated islands. The Virgo supercluster, our neighborhood, will remain intact, but it will separate from Pavo Indus and Hydra Centaurus. The Great Attractor will remain an unattainable dream. We will see it, but we will never be able to get close to it. It will float away from us along with the expanding space. In the distant future, in 100 billion years, for an observer from the Milky Way, the universe will become a very lonely place. Other superclusters will disappear beyond the visible horizon. Light from them will stop reaching us. Even parts of our own Laniakea will float away into the darkness. Only our local island will remain, the merged Milky Way and Andromeda. We live in a unique time, in the era of structures. We manage to appear exactly when Laniakea is still visible as a unified whole, when the currents are still flowing and the bonds are not yet broken. We see beauty that will not exist forever. Laniakea is a temporary pattern on the surface of an expanding bubble. But even this knowledge doesn't make it less majestic. On the contrary, fragility adds value. We are the only ones who can realize this scale and put it on a map. Let's go back to exactly how we did it. The method of Brent Tully and his team, which allowed the discovery of Laniakea, deserves special attention. They used the Wiener filter. This is a complex mathematical algorithm that allows separating signal from noise. In data on galaxy movement, there is a lot of noise, measurement errors, random jerks. But this algorithm allowed smoothing the data and seeing global trends. They built a three-dimensional map where flows of galaxies were shown as streamlines, looking like hair. White threads on a black background, twisting and weaving into knots. When they first saw this image, they realized that the old borders on maps were just arbitrary lines, like borders of states in Africa, drawn with a ruler by colonizers without regard for terrain or peoples. Laniakea is a natural border. It is a nation of galaxies united by a common destiny of movement. But what is inside? If Laniakea is our home, then where in this house is the kitchen? And where is the bedroom? The center, the Great Attractor, is undoubtedly the hearth, the hottest and densest place. That is where the most active interaction takes place. But there are quiet corners too. We live in the local sheet. It is a flat structure, like a pancake, located on the outskirts of the Virgo supercluster. Our sheet moves at a speed slightly different from the general flow. We are sort of swimming with the current, but also paddling a bit to the side. And right next to us is absolute emptiness. The local void. We already talked about it, but its role cannot be underestimated. This void is not just an absence of matter. It is an active participant in forming our home. It is growing. Voids in the universe have a tendency to expand, compressing matter into walls. The local void is inflating, and its walls are us. We live on the shell of a giant inflating bubble of nothingness. This creates an amazing geometry. Laniakea is porous. It looks like a sponge or breadcrumb. Dense filaments of galaxies surround huge caverns of emptiness. Matter makes up only a small fraction of Laniakea's volume, but it creates its frame. If you could fly out beyond Laniakea and look at it from the side, what would you see? It would be a faintly glowing, fibrous cloud. Clumps of light at the nodes, thin threads of bridges, and blackness inside. Set against the even deeper blackness of inter-supercluster space, it is not a solid object. It is more like a mist, but a mist that has a rigid structure. And here we come to another deeper layer. Dark matter. We talked about gravity and dark energy. But there is another player often forgotten. The visible galaxies, all those 100,000 island stars that make up Laniakea, they are just the cherry on top. They are glowing beacons floating in an ocean of invisible dark matter. It is dark matter that creates those very riverbeds along which galaxies flow. Without dark matter, Laniakea could not exist. Its gravity wouldn't be enough to hold such a structure even for a moment. When we look at a map of Laniakea, we are actually looking at a map of dark matter distribution. Galaxies just highlight it for us. We see the skeleton of an invisible entity thanks to glowing bacteria on its bones. This changes the perception of reality. We are used to thinking that stars and gas are the main things, but on the scale of Laniakea, we are just foam on the waves of a dark ocean. We move where dark matter flows. We clump together where it clumps together. The Great Attractor is primarily a giant lump of dark matter, and only then, a cluster of galaxies. This realization makes us even smaller. We aren't just a grain of sand in the ocean. We are a grain of sand made of rare, exotic material, baryonic matter, floating in an ocean of a completely alien substance. And now, let's return to the name. Laniakea, Immeasurable Heavens. This name was given by Hawaiian navigators, the very people who knew how to find tiny islands in the Pacific Ocean, guiding themselves only by stars and currents. There is a deep irony and beauty in this. We, modern astronomers, use the same methods. We look at currents, cosmic flows. We look for islands, galaxy clusters. We are the new navigators in an ocean billions of times larger than the Pacific. And we have only started drawing our first map. The map of Laniakea is just the beginning. The cosmic flows. Methodology allows us to look further. Astronomers are already starting to outline the contours of Laniakea's neighbors. They see hints of super clusters. Maybe Laniakea and Perseus Pisces are parts of an even larger structure. Hyperclusters? Some data points to the existence of the so-called South Pole Wall, a dense structure located right behind the southern edge of our galaxy, which we can barely see. It also borders Laniakea. The universe is a fractal. Structures repeat at different scales. Planetary systems, galaxies, clusters, superclusters, walls. Where is the limit? Is there a scale at which the universe finally becomes homogeneous? The Standard Model says yes. That on scales larger than 1 billion light-years, the universe should be smooth. But discoveries of monsters like Laniakea, 500 million years, or the Hercules Corona Borealis Great Wall, 10 billion years, make us doubt. Maybe the hierarchy continues infinitely. Maybe our Laniakea is just an atom in the body of a being whose size we cannot even imagine. We are approaching the conclusion of our analysis. We have dissected the anatomy of our home. We realized we live in a dynamic, fluid, living world, governed by invisible forces of dark matter and dark energy. We learned that our address in the universe is much longer and more complex than we thought. But one last, most important question remains. The question of meaning. If we are part of such a huge system, if we are a neuron in the brain of God, a cell in the circulatory system of a giant, then what is our role? Are we just observers? Or are we the universe's way of becoming aware of itself? After all, without us, without our minds, without our telescopes, Laniakea would exist, but it wouldn't have a name. It would just be a mute, blind mass falling into the void. We gave it a name. We gave it a form. We, tiny creatures on the third planet from a yellow dwarf, made this structure real by realizing it. Now, let's descend from the heavens to Earth and talk about how the discovery of Laniakea affects our future. We will discuss the zone of avoidance, that blind spot hiding the heart of our home from us, and learn how new technologies will finally allow us to see the Great Attractor face to face. We will talk about whether we are in real danger from this fall, and if humanity can ever leave Laniakea. And finally, we will link Laniakea to other great mysteries of the cosmos, the cold spot, and the axis of evil. The deepest conclusions are yet to come. We just realized the size of our cell. Now it is time to understand if we can get out of it. We have reached the final line of our investigation. Now we know the name of our home, Laniakea. We know its shape. We know its dynamics. But there is one detail that gives this whole story a taste of bitter irony. Fate played a cruel joke on us. We found out that all the galaxies of our supercluster flow toward the Great Attractor. We understood that the heart of our world lies there, but we cannot look at it. Right now, if you go outside and look in the direction of the constellation Norma, you will see nothing. Or rather, you will see the beautiful band of the Milky Way. Stars, dust, gas. It is beautiful, but it is a wall. Astronomers call this the zone of avoidance. It is the curse of our science. Our own galaxy, our home, blocks our view of the most interesting place in the universe. The dust of the Milky Way absorbs visible light, working like a thick curtain. We are sitting in the front row of the theater, but there is a pillar right in front of us. Imagine how frustrating that is. We calculated where the center is. We feel it pulling us with incredible force, but we can't see it. We only see indirect signs. Gravity punches through the dust. X-rays punch through. Radio waves punch through. And it is with the help of these invisible eyes that we make guesses. We know that there, behind the dust curtain, a monster is hiding. The Norma cluster is just part of it. There is something else. Something we currently just call mass. Perhaps in the coming decades, with the launch of new space telescopes working in the infrared range, we will finally wipe the glass and see the face of the one who controls our movement. But let's look away from what we can't see and talk about what awaits us. We are flying. We are falling. 600 kilometers per second. Is it dangerous? Are we threatened by a collision? The direct answer is no. In the near future, we are in no danger. Space is too empty. Even if we are flying into the thick of events, the probability of star collision is vanishingly small. Galaxies can pass through each other like ghosts. The danger isn't in collision. The danger is in loneliness. We already said that Laniakea is doomed. Dark energy is tearing it apart. But let's imagine what will happen to us, to humanity, if we survive. In billions of years, the sky will change. Other galaxies that are currently part of our feather will float away over the horizon. The bonds will break. We will remain locked in the local group. The Milky Way and Andromeda will merge. It will be a grand fireworks display that will last hundreds of millions of years. New stars will be born. The night skies will be ablaze. But when this party is over, we will find ourselves on an island in the middle of an infinite black ocean. Laniakea will cease to exist as a unified structure. It will remain only in old star charts, which perhaps our descendants will study. They will read about the great rivers of galaxies, about the cosmic web, but they will see only darkness. For them, our era is a time of legends, a time when the universe was rich, crowded, and connected. This makes you think about the value of the moment. We live in the golden age of astronomy. We see what will soon become invisible. But there is another aspect, the technological one. We are locked in Laniakea not only by gravity, but also by distance. 500 million light-years. Even if we invent an engine capable of reaching the speed of light, it would take us 500 million years just to cross our neighborhood. This makes intergalactic travel practically impossible within the laws of physics known to us. Laniakea is our cage. Spacious, beautiful, full of wonders, but a cage. We will never leave its limits. We will never see what is in the Perseus-Pisces supercluster. We will never reach Shapley. We are forever tied to this flow. And yet, realizing that we are part of Laniakea changes our worldview. Before, we thought Earth was the center of the world. Then, that the Sun was. Then we realized we were on the outskirts of the galaxy. Now we know that our galaxy is just a grain of sand in a stream rushing into a gravitational funnel. It teaches humility, but it also elevates. Think about how we learned this. We, small creatures living only a few dozen years, were able to map an object that lives for billions of years and has a size that boggles the mind. We used light, mathematics, and silicon chips to see the invisible. We untangled the knot of gravity. Brent Tully's team didn't stop at Laniakea. They are continuing their work right now. The Cosmic Flows 4.1 catalog already contains data on tens of thousands of galaxies. The map is expanding. We are starting to see the contours of Laniakea's neighbors more clearly. We see the South Pole Wall. We see the voids that surround us. We are building a globe of the universe. And the more we see, the more questions arise. Why is the universe built exactly like this? Why does it look like a web? Why does it look like a brain? There is a theory that this structure is a trace of quantum fluctuations at the moment of the Big Bang. Microscopic ripples on the fabric of reality in the first fractions of a second were blown up by inflation to gigantic sizes. Laniakea is a frozen echo of the birth of the world. Looking at it, we are looking into the face of the Creator, whatever or whoever that may be. And what about other theories? The axis of evil we mentioned, a strange line running through the universe. Some scientists claim that the orientation of Laniakea and other superclusters is not accidental, that they are aligned along invisible force lines. This could indicate that the universe is rotating, or that it has a complex topology, like a donut or a Mobius strip. Laniakea is a piece of the puzzle, a very large piece. But we don't see the whole picture on the box yet. We are completing our journey through the immeasurable heavens. We started with the fact that our address has changed, but in reality, we have changed. We are no longer residents of a lonely farm. We are residents of a metropolis. In this metropolis, there are traffic jams, galaxy clusters. There are empty lots, voids. There are highways, filaments. And there is a center, the Great Attractor. It is a living, breathing system. And even if it is doomed to decay in the distant future, right now it is beautiful. It is full of motion. The next time you look at the night sky, remember, you are not standing still. You are flying. You are part of a great river. You are a drop in the flow of Laniakea. And this flight is the grandest journey imaginable. But Laniakea is not the only mystery. Remember we talked about how we are not only being pulled, but also pushed? That behind us lies a frightening emptiness, the local void? Well, this emptiness is just a small part of what the darkness hides. There are places in the universe where there is nothing, absolutely nothing. Places that scare astronomers even more than black holes. The most famous of such places is the Eridanus supervoid, the cold spot, a hole in reality that might be a scar from a collision with another universe. If Laniakea is our home, then the Eridanus supervoid is a hole in the wall of our house through which an icy wind from the multiverse blows. I will tell you about this, about the largest and scariest emptiness in the next video. It has already appeared on your screen. If you were impressed by the scale of our full universe, then the scale of the empty universe will make you shudder. Click and continue exploring the abyss with us. The cosmos is closer than it seems. See you there.